Hi there. Let's take a look at 11.1b where we are multiplying and dividing rational expressions. All right, so rational expressions means you're going to have fractions with variables in the denominator. So yeah, we got a lot of variables here. All right, if you will recall, you multiply fractions straight across. So I'm basically going to take my 4x squared times my 15x and get my numerator. And then I do the same thing in the denominator. However, it is nice to try to reduce before you multiply. That can make your life a little bit easier, and this one definitely has some reducing that you can do. If you look at when you're trying to reduce, for instance, let me throw over here an example with just numbers. If you had a 2/3 times, let's say, 9/10 or something like that, I could multiply straight across, but it's nice to be able to reduce because, for instance, I could reduce right here. I can divide both of these values by 2, so that's going to become 1 and 5. I can even divide this way. They both can divide by 3, so that would give me a 1 and a 3, and then multiply straight across, and you end up with 3/5. By reducing at this stage, it saves you from having to reduce at the end, and it keeps your numbers much smaller because sometimes they get so big it's hard to know what it reduces to. All right, now, so to reduce, you have to have something on the top and something on the bottom. So in this case, they were catty-corner there from each other, but it can be something right on top of each other. As long as you have one item on top and one on bottom, you can reduce that way. So let's look at the example I've got. So what I see, it looks like I could reduce this 5 and this 15 because they both divide by 5. So that'd be a 1 and a 3. I can also divide the 4 and the 16 because they're both divisible by 4. So that'd be a 1 and that'd be a 4. But we also can reduce variables. And so when I look at this, x squared, I would be looking for x's on the bottom to try to reduce. Unfortunately, they're not the right letter. They're y's. Okay, so all of my x's are on top and my y's are on the bottom, so there isn't any reducing that I can do there. But if by chance this right here was like a y, then I could cross those out. Even if it was a y squared, I could cross one of them out on top and one on bottom kind of thing. We'll do some that have that. Right now, it doesn't look like there's any reducing I can do, so I'm just going to multiply straight across, and I have an x squared times a 3x, which is going to get me a 3x cubed. On the bottom, I have a y times a 4y squared, so that's going to get me a 4, and then I'm going to end up with a y cubed because I have 3 of them down there. And that's my answer. Okay, let's try something different. What if you have some addition and subtraction going on these problems? All right, here's the rule with this. As soon as you have some addition, like right here, I cannot split these two things up because I'm taking in and I'm dividing by this entire quantity. So anytime I see addition or subtraction, I immediately stick some parentheses around that to group it together to remind me that I can't piece it apart. Dividing, like in these fractions, division can be undone with multiplication, so if there are things being multiplied, it's okay to reduce them, but not if they're being added or subtracted. So over here, I'm going to put parentheses around that because there's addition. I'm going to put parentheses around that because there is addition, and that groups it. Now, if there was something being multiplied, then it's fair game to try to reduce. So actually, what I'm going to do is look at these two right here and say, well, those look like something that could actually factor. So we're going to do a lot of factoring with these rationals. So the first thing I'm going to do is look at this trinomial, and I'm going to split it up and factor it to an m. Factors of 18 are going to be 6 and 3. They're both pluses. In the denominator, it looks like on this one that I could pull out a GCF. I could pull out an n, and then I'd have an m plus 3 left. On the right side, there's no factoring that can be done, so I'm just going to rewrite it. Okay, so here's what's nice about this. By factoring, I've suddenly created multiplication. Right there, those two things are being multiplied. Right here, these are being multiplied. As soon as I multiply them, now I have the ability to be able to reduce. So on the top, since I'm multiplying right here, this quantity could be separated from this quantity. And so what I'm looking to do is to be able to reduce the quantities, which I can certainly do. Right here I have an m plus 3. I have an identical m plus 3 in the bottom. I'm going to divide those out. Remember, when you cross things out, you leave 1 in their place. Okay, I have this n right here that can reduce with this n, so I'll cross those off. Oh my goodness, I also have an m plus 6 that can divide with this m plus 6. I got every single thing to cross off. Now, that's not common. Usually there's something left, but in this case, every quantity crossed off, and what I have left is 1 over 1, or just 1. And that's my final answer. That worked out beautifully. Let's try one more. Probably not going to work out quite as beautifully, but notice on this one that this is division. I had a heck of a time getting my division sign in there. It wouldn't let me do it, so that's kind of a ugly division, but that's what we're doing. We're going to divide these. Okay, so here's the process. We do not divide by fractions. Remember that you change this to multiplying by the reciprocal. So I'm going to change this to multiplication, and I'm going to flip this. Okay. I also see over here something that looks like it could be factored. So I'm going to do kind of both of those in one step. So let's start with this numerator. Looks like we can pull out a v. Then I'll have a w plus 8 left. And the denominator, it's a trinomial that's going to factor. I'm going to have a w, factors of 24. That'll add up to 11. I think that's going to be 8 and 3. Signs are the same. They're both going to be pluses. And now I'm going to change this to a multiplication problem. Anytime you see division, you'll change it to multiplication and then flip that second fraction. Okay. Now we're going to look to reduce stuff. W plus 3's cross off. W plus 8's cross off. V's cross off. Okay, I lied. Apparently, I just pulled these off the software, so apparently they like to have everything cross off. So, again, doesn't have to happen that way. Remember, when you cross things off, you're really supposed to be leaving 1 in their place, so I end up with 1 over 1 again, which is a 1. Okay, so there you go. Good luck.